think it's out of storage.
What that basically means, right?
Yeah.
Is that I can access all the features of a Raspberry Pi from the surface. We're just communicating via Ethernet. So with that, that's how we start up the program, right? I VNC in, I basically, it pulls up the desktop, I start my brain. Once my brain's running, basically I have my laptop right here. This program is our driving program. So I start that after brain's been established. So once they're started, they communicate through sockets request, which is kind of like an HTTP request, but it's a little different. But so basically then every time we send, every time our pilot uses the control stick, a packet of data is sent down the tether all the way to the brain for it to be unpackaged and then evaluated, and then based off on what the input was, it'll do different, it'll communicate to the Arduino to fire different pins. So then the last thing is our camera feed. So our camera feed is, like I said, plugged into the Raspberry Pi. So what you do is you send it up via GStreamer. So GStreamer basically establishes the streams and sends them to the ports. And so then we have a program called Docker. So Docker basically will run a virtual environment for us. I believe we have a Debian Linux virtual environment with class and certain repositories that allow us to establish a web page that will show the camera streams. Basically what that means is that on Docker we say which ports we want open, and that's where GStreamer sends those ports. I believe they're 5601, 5602, 5603, or something along the lines of that. With those ports open, the streams are sent up the tether, Docker. So it's a virtual environment. It's not really a virtual, it's a container. So just kind of think of it like a virtual environment. So your source code isn't stored on a virtual machine. It's still stored on your local memory. So what Docker does is it runs, it takes the code, basically we made an anchor point in our directory where our program is stored, and it'll basically reestablish that directory in the virtual, in the container, and basically we run it there rather than on our the local machine with that version of Python. We run it with the specified version of Python on a different OS. Once Docker is running, a web page is made. 192.168.1.10. You put that in, you basically open that up on our browser, right? Because our laptop is Ethernet in, and then basically what you see is your camera's view is established. And then you can switch between all three cameras via just clicking these buttons here. The last thing to cover is our claw. So our claw uses a really high-rated linear actuator. It's really beefy. It's about 20 pounds of force, which maybe isn't necessarily a lot, but it's very reliant and robust, and it does super well at the bottom of the pool. Okay, it's rated for all depths.
Yeah.
And so what you see here, right, on the back of the claw, right, we have a servo attached. So the servo basically is rated for underwater. We also I think we plotted it. So the servo runs back through, and it's like, there's a penetrator in the back. We send the servo back up to the Arduino where we control the claw. And then the claw for this craft uses a linear, uses relays. For that craft, we use a Palulu, which is basically a motor controller, but the motor controller is able to like a motor controller works by basically like fine tuning reverse polarity.
Okay.
For that, we don't need to fine tune it, we can just send it back. That's totally different.
Yeah. Thanks.
All right. Thank you for your time.
Yeah, we have to go.